Most automotive PNT systems will utilize Global Navigation Satellite Systems, or GNSS, to provide absolute positioning information. This data will be augmented and toughened through various combinations of other sensors. The criticality of that PNT information depends on the function of the data. In its most basic form, PNT provides a luxury feature in the form of an in-vehicle navigation system. Drivers can choose to use this IVNS to follow an efficient or quick route. For vehicles seeking to achieve SAE Level 3 and higher, the performance of the PNT systems and subsystems is inherently critical. Driver assistance and autonomous driving functions can be responsible for road position, navigation, speed, and collision avoidance. Failure of PNT systems in these applications can have devastating consequences. PNT testing enables automotive developers, whether they are Tier 2 or Tier 1 suppliers, OEMs, or service providers, to understand and improve the performance of their positioning, navigation, and timing systems. The go-to option for validation testing is simulation. Simulation enables an infinite range of tests and test conditions to be realized in repeatable lab environments. The Spirent GSS7000 is a multi-frequency, multi-GNSS simulation system that supports a wide range of test applications for GNSS and additional PNT testing. Performance and consistency are assured through the dedicated, low-noise architecture. 4-millisecond system latency and seamless integration with the leading hardware-in-the-loop simulators ensures hill testing delivers the deterministic results needed. The ability to emulate sensor outputs in concert with GNSS enables extensive testing of sensor fusion without complicated and expensive stimulation of inertial sensors. To support the testing of high-accuracy augmented GNSS, the GSS7000 can broadcast real-time correction messages for RTK and PPP. And simulations are enriched through enhanced environmental realism and absolute control over all aspects of the simulation. The GSS7000 supports the complete spectrum of current and planned open-service GNSS signals, as well as SBAS and other LEO PNT signals. The SIM sensor function in the GNSS control software enables emulation of MEMS sensor outputs in concert with GNSS. This enables testing of integrated GNSS and inertial sensors and the algorithms that control them for reliable and precise positioning. This feature allows editing of a wide range of variables according to the specifics of the sensors under test. Variables such as the deterministic errors and stochastic errors for sensors such as gyros, accelerometers, and wheel ticks can be fully and easily edited by the user. Environmental errors such as vibration and temperature-induced fluctuations can also be added. Autonomous vehicles and vehicles with higher levels of ADAS can be vulnerable to malicious attacks such as spoofing, which have already been shown to have serious consequences in the real world. In order to test and improve resilience to spoofing attacks, the GSS7000 supports simulating a wide range of attack types, such as beaconing, navigation data spoofing, trajectory spoofing, and more. Users can set up spoofer transmitters to simulate the antennas broadcasting the spoofing signals in the simulated environment. The software will calculate the time delays and power level fluctuations of the spoofing signals according to the stated positions relative to the vehicle under test, so that they are more realistic. The user could also set up a trajectory for the spoof vehicle, as well as for the truth vehicle. This creates a typical trajectory spoofing scenario. The GSS7000 has the native capability to generate jamming and interference signals including CW, chirp, PSK, and AWGN. Jamming antennas can be static or dynamic in the scenario, or can be positioned relative to the vehicle under test. Sim3D enables the creation of 3D environment models that deliver highly realistic multipath and obscuration signatures for enrichment of the scenario. Signal attenuation and blockage information, and even angle of arrival for over-the-air tests is passed to POSAP for it to be applied to generated signals. SimHill enables plug-and-play integration of the GSS7000 into hardware-in-the-loop test setups. Using Spirent's open and rich API, users can take advantage of the stable 4-millisecond system latency to deliver deterministic results. Once a scenario is configured, users can simply hit the Run button and the GSS7000 will generate the corresponding RF with high fidelity. And all the observables, including truth data, can be logged or streamed according to user preferences. The simulation is running. The simulated vehicle is on the specified route with interference impacting the GNSS signals and spoofing signals confusing the vehicle under test. At the same time, the emulated inertial sensor data, corresponding to the simulated vehicle motion, are streamed to the vehicle under test. With the Spirent GSS7000, automotive developers can save time and money throughout the development and validation cycle, generating deterministic results, removing the uncertainty introduced through lower quality test instruments, accelerates development, and minimizes the possibility of costly failures and even recalls. As the criticality of PNT increases for automotive applications, the margin for error decreases. The GSS7000 delivers the realism and performance needed to make it the partner of choice for the industry.